Welcome to another fun-filled edition of Comet Algebra. This video is for Algebra 2, Chapter 3, Section 2, Ratios and Proportions. So we'll start with a few terms. A ratio is a comparison of two numbers by division. Usually in algebra we'll write it as a fraction. Like an example is 3 to 2. That's what it would look like as a fraction. We could also write it with a colon, 3 to 2 like that, or even using the word 2. Now, no matter which form you use, you always do put ratios into lowest terms. You reduce them down. Next term is a rate. A rate is a ratio comparing numbers with different units. An example could be like 3 miles in, say, 30 minutes. Okay, two different units, miles and minutes. And if we did write this ratio, we would want to reduce that down to 1 mile in 10 minutes. A unit rate is a fraction like we just did a rate, except when the denominator is 1. So an example of a unit rate could be like if you traveled 50 miles in 1 hour, because the bottom number is a 1. You might use unit rates when you're comparing prices for items. If you're buying soup and you want to compare the two sizes of cans, perhaps one of the cans would be 10 cents per ounce for 1 ounce, and maybe the other can of soup is 12 cents per ounce. If you divide it down, and I guess I could put a 1 here, 1 ounce, 10 cents per 1 ounce or 12 cents. That's supposed to be a 1. And then unit rates make it easy to compare prices on things to see which one is the better deal. Okay, this next term is a unit multiplier. Now this is kind of hard to define, but perhaps with an example that'll help. It's a fraction with different units on the top and the bottom that are actually equal to each other. And we use this in conversion problems. Quick example, let's say if something, I guess it would have to be a rocket or something to go this fast. If something was traveling 200 feet per second, and you were asked to change this into feet per minute, you have to come up with a unit multiplier that would do that for you. This part here in blue is the unit multiplier. If we want to change this to feet per minute, we want the seconds to go away. So if you kind of remember this, we put seconds in the numerator because it's in the denominator in the original. And if we want to get to minutes in feet per minute, we'll put the minutes down here. And then this is the equivalent. 1 minute is equal to 60 seconds. So this multiplier here that I wrote in blue, this is the unit multiplier. And then we would go ahead and use that to do the multiplying. The seconds, the word seconds would cancel. And then we'd end up with 12,000 feet per minute. Okay. So this part in blue is the unit multiplier, and we're going to be using those to do conversions. All right, the next term to define is the word proportion. And this is simply defined as two equal ratios. Oh, for example, if we had 4/12 is equal to x over 10, this is a proportion. The ratios are equal. These terms, means and extremes, are used in your book, so I thought I would put them in your notes here. They're not used very much. I don't think I've seen them in the rest of the book except for this assignment, but they just I just wanted you to have that to refer to. And because we have extremes over means equals means over extremes, then we can say this sentence: the product of the extremes equals the product of the means. Now, maybe that doesn't make a lot of sense yet, so let's look at it more algebraically. If we have a over b equal to c over d, Another way to say this, perhaps in words, the cross products are equal. Now this doesn't sound like a very big deal, but this is very, very powerful in math. And you may ask, where did this come from? Well, let's think of a common example here. I think we would all agree that 1/2 is the exact same thing as 6/12. And then if we looked at their cross products, 1 times 12 is 12, and 2 times 6 is 12. Again, it doesn't look very impressive, but this is very powerful and it can be used to solve many, many problems. So that's why we wrote it here. A over B equals C over D gives us that AD equals BC. So again, very powerful, very important. Write this down and then we'll learn how to use it to solve problems. All right, let's look at a few examples together. Sometimes a ratio is a part to a total. Like this A says girls to students in our example. Well, part of the students are girls, so this is a part to total. The girls are 168, the total students are 312, and we do reduce that, which I think reduces down to 7/13, if I did that right. Sometimes they don't give you a number and you have to go after it and find it. Here we're not given the number of boys, so we have to do a quick subtract to find that there are 144 boys of the 312 students. And if I reduce that down, I think it reduces to 6/13. This next one, part C, this is a part-to-part ratio. Part of the students are girls, part are boys. So the number of girls is 168 over the boys is 144, and that reduces down to 7/6. Part D says find the unit rate of students per teacher. So when we see unit rate, we're thinking of 1. Okay, uno is Spanish for 1, so unit is 1. So we're going to have to do something to make sure our bottom number is 1. Well, students per teachers, we know there is 312 students and 20 teachers. Now this doesn't reduce down so that the bottom number is 1. So to make sure that happens, you need to divide. So go ahead and do on your calculator 312 divided by 20, and we end up with 15.6 students per teacher. In other words, 15.6 students for one teacher. And this is a number that they use to compare schools to parents are interested in class size, and so that statistic can be very useful. In example 2, we're going to do some conversions. So we have 28 feet. So I'm just going to write that 28 feet. It helps me to put it over 1. If you don't want to, you certainly don't have to. But we're going to multiply that, a unit multiplier. We want the word feet to go away, to be canceled, and we want to end up in yards. So if the feet is in the numerator here, it must go in the denominator in my multiplier, and I want to be left with yards. So we're going to put that in the numerator. And we know that yards are bigger, so 1 yard, common knowledge, we know it's 3 feet. And so now when we multiply these two fractions, the word feet, feet divided by feet is 1, that goes away. So we end up with 28 over 3, and we do need to divide that, and we'll just round off. So this rounds off to approximately 9.3 yards. This next part in B, we are asked to convert inches into centimeters. So same way, 62 inches. I'm just going to put it over 1 because that helps me visually to see. Inches on top here, inches on bottom here. I want centimeters, so that's in my numerator. We're given the conversion factor right there, very handy. 1 inch is 2.54 centimeters. Now this answers the question of, is it a divide problem or a multiply problem? Okay, part A was a divide problem. This one, part B, is a multiply. So if we go ahead and multiply 62 times 2.54, and I think we got to round off a little bit, I end up with 157.48 centimeters. No, I guess we don't have to round off. We got it exactly. All right, our next example says, what is the average speed in miles per hour? So let's take note of that. We want it in miles per hour of a runner who runs the 400-yard dash in exactly 1 minute. So we're given a piece of information. We're given that she ran the race. She went 440 yards in 1 minute. Okay, this is the given information. And we want to do some conversions so that when we're all done here, way at the end, we have a number in miles per hour. So we have to change the yards into miles and the minutes into hours. And it really doesn't matter which one you do first, you just have to select one. So we're going to set up our multiplier. If we decide to go ahead and change the yards into miles first, so again, yards is on top there, we need to put it on the bottom here so that it cancels. We do not want yards, we want miles, so we'll put that up here. And we would either have to look this up or we would have to be given the fact that there's 1,760 yards in a mile. So put the 1 there, the 1760 here, and you can go ahead and divide that. The yards would cancel. And we would end up with 0.25 miles in 1 minute. So we're halfway there. We want miles per hour and we have miles per minute. So we want this minute to go away. Set up another multiplier. If the minute is down here, we want to put the minutes in the numerator so that minutes cancel. We don't want minutes, we want hours, so we'll put the word hours here. This is common knowledge. You know that 1 hour is 60 minutes. And so now if we multiply 60 times 0.25, and we see that the word minutes here cancel, we end up with 15 miles per hour is how fast she ran. Not too bad. Next example. Solve the proportion. 7 over 8 equals x over 4. Now since we know that the cross products are equal, we use that fact to solve this problem. Cross product is 8 times x equals this cross product is 28. And now, knowing what we know how to solve for algebra, we divide both sides by 8 and we get x equals, well, 28 over 8 reduces down to 7/2. In this next one, we are going to use cross products to solve it. In the previous chapter, in chapter 2, we multiplied both sides by the common denominator, which worked really well. Well, we're going to learn another method here. I'm going to go ahead and put my numerators in parentheses, and then we're going to cross multiply. I'll just put my x here so you can kind of see it. So we're going to take 4 times x plus 8, and that is equal to 6 times x plus 3. Now it was nice to put the parentheses in there because that helps me see the distribution. So go ahead and distribute. Now let's do the undoing method here and get the x's together on one side and the numbers together on the other. Last step is to divide both sides by 2, and we'd get x equals 7 as our final answer. All right, one more example is a straight up proportion problem. If a car uses 12 gallons of gas to travel 320 miles, now there's many different correct ways to set this up, and I'm just going to choose one of them that I guess I like to use. So if I have 12 gallons and I drive 320 miles, how much gas, that's the x, how much gas would be needed to go 500 miles? So we cross multiply. 320 times x equals 12 times 500, which is 6,000. And then if we divide both sides by 320, we'd get x equals 18.75. And the units we found was gallons. All right, now you should have the knowledge you need for section 3.2, so have fun with math.